So today we are going to solve Codeforces Problem Difficulty Level 1400. Today I am going to solve with these four problems: 1628A to 1609C. Okay, these four. Oh man. Or I'm just next four problems. Okay, these four problems. Okay. So jump into the first problem. So me, I just learned about MEX concept, and since he liked it so much, so he decided to use it right away. Given an array A of non-negative integer, may I want to create a new array B is formed in the following way. While A is not empty, choose an integer k between 1 to size of A. Append the mx of first k number of array A to the end of array B and erase them from array A. Shift the position of the remaining numbers in A. Since May loves this big arrays as much so as the MEX concept, so he wants the new array BB lexicographically maximum. So may I ask you tell him what the maximum array B can be created by constructing the array optimally. An array X is lexicographically greater than array Y if some number is greater. Okay. Okay. So what I given is that we are given an array A1 to AN. Okay. So if like in this type of problem, so what we have to do is, how do we approach? We will suppose let we have this. Okay, so first of all, so let me have MEX of this current array. So I'm having the current array A1 to N. Let's MEX is something something number like 5 let's say it will be 5. So I need to find, so what I need to do is, first of all, I need an array B. So what B gonna be? B gonna be like MEX of the array. Like first of all, the MEX. What I need MEX should be the max to be max. So I have the remaining array something. So I need the MEX should be the maximum. So maximum, when it will be maximum, if I'm taking the whole array, so I need to find the maximum of the remaining array, and then I have to like somehow see that up to which point it can be find out. Okay. Okay, so that's I need to have to do, so something like that. I have an array 1 0 2 3 uh, 4 1 0 2 5 4. Okay. So I'm saying that the MEX of this array is completely 5. From 0 to 4 all elements are present, so MEX is 5. So I need to find something like starting from this point. It is always starting from this point. Okay, from k is equal to 1, or it is always saying that delete all the first k elements. So I need to find out which is the element up to where I can find this same MEX. So I'm saying up to this position, starting from this up to this position, I can find MEX. Okay, because from here to here, from this L to R, for this range, for this subarray, starting from 4 to and at 3, this is also containing all the elements from 0 to 4. So I'm saying that, so it will be max. So I'm just creating my array B, append the 5 at the end, and erasing all these elements. Now I'm going to do same for the all the elements, the remaining elements. These are this type of protocol I have to follow. Okay, yeah, that's how we are just gonna do calculate the array B. So first of all, I need to calculate the array, the MEX from A1 to AN. Let's say it's come 5. It's come out 5. So I need to find what is the first element. I encounter all the elements from 0 to 4. So I'm starting from here and move to here. Seeing the MEX is 5. No. is now, let's say up to this point I encounter all the elements from 0 to 4. So now I am encounter the all the elements. So what I need to do, so I just hop it this 5 into the my new array B, and try to find out all what is the mex from a5 to an. So let's say mex comes to be 4, then I'll applying the same process and counter up to which limit I'm gonna find all the elements from 0 to 3, then I'm pushing the 4 element in the array B. This is the same I'm gonna to apply. This is what we have to do. So what we need to find is, first of all, I need to find mex. So what is the at most complexity I can give to finding the mex, so my solution will be accepted. So I will say I need to iterate all n elements and I need to find mex. So maximum possible can be log of n, or so I need to find mex in log of n or O of n, O of 1. Okay. So first task is, so now first of all I'm what I'm trying to do is I'm trying to break my problem into small party on the small problems. So first problem I need to find mex from any position I to a of n. That's my first problem. Any position I to the last element I need to find mex. Okay. In log of n or O of 1. That is completely fine. Second problem, if I get to know about mex, let's say now I'm get to know mex, but now what I will want to do is I need to do what is the first element I encountered, or the elements, like from 0 to 4 I have all the elements. So which can be done by, let's say, easily I'm using the set. Okay, so I'm starting from 1. So whatever, how can we do? So it can be doing by using set. So let's say this is the task 1 we have to do, this is the task 2 which I need to do. So I'm saying this can be easily done by set. So how can it is done by set? So let's say I'm starting from a1. So first of all I see that this element is smaller than mex or not. So let's say I'm taking an example that will be more good. Okay, 2 0 4 6 1 3 2 0 1 4. Okay, so I am say that I need to first find the mex. This is task 1 from, this is array from the 1 to n. Okay, so I come up with mex for by somehow, let's say, but this is my task 1, so I will gonna solve it later. So first of all I'm seeing how to do in task 2, that is, mm, up to the minimum element we need to find that mex from starting from a of I. So I come up with, okay, so mex is 5, because 5 is not present in this array. So I'm saying I'm just using the set and easily find out it. So how can this is my set. So first of all I'm checking now I need a little bit space. This is my set. I'm checking the current is 2. It is smaller than 5. I'm saying yeah, it is smaller than my current mex. So I will insert into my set. Okay. Now then another element is 4 0. Now I'm inserting in this element. Next element is 4. It is smaller. I'm inserting. Next element is 6. No, it is not it is not smaller than 6 5. I'm not going to insert. Let's say 1. Yeah, it is smaller. I'm going to insert it. And next is 3. It is smaller. So when the size of this set is become to our current mex. So now the size is 1 2 3 4 5. So yeah, at the last element I inserted is 3. So I'm saying that from the this position to this position I am getting all the values 0 to 5, because set only contain values only repetition, it is not allowing any repetitions. So all element will be at most present by one time, and I'm only allowing the value that are greater less than mex. So if the size is equal, then I am 100% sure that all elements are present. Yeah. So second task is solved easily using mex, using set. I hope this is understand, this is crystal clear for all of you, man. So now we have one task remaining. We need to find out MEX. So let's see the task. So what is the task is, for any I, let's say this position to up to AN, I need to find MEX. In what is the required to complexity of log of n or O of 1. This can I can afford that much. Okay. So I'm seeing that, let's say I need to this one, let's say I'm just starting from the end. Okay, I will also gonna tell you why I'm taking the decision that I'm gonna starting from the end, why it is be good. Okay, so let's say I find out the MEX from here to here. Okay. That is, let's say 3. Now I also need to find out, let's say this is A of 10, A of 8, A of 9, all of these elements. So if I am already find out the MEX of 10, A of 10, so for the 9, A of 9, A of 9 to A of n. So I'm saying that this all the element of A of 10 are already in the set. So it will be, I'm not have to read, or I don't have to check, I don't have to worry about all the elements that are smaller to the 3. So I'm 100% sure that MEX of this element is greater than 3. So it will be, you can see that it will be beneficial. So if we are just starting from the end, because at all the time we need the suffix MEX from AI to AN. Okay, if you see in the problem, like from here to here I'm got the solution mex, that is the first mex, then I need to find the mex from here to last a of n. Okay, so it is will be always be good to find the mex from last. So I'm starting from the last, that's it. So there are so many ways so we can find the mex. Okay, we can use a count array and increase the value at all the, let's say I'm increasing this a of 10, I say I'm increasing this value, and current mex is 3. So I'm saying if 3 is percent, then I'm gonna increase mex plus plus, same for all these. Okay, so let's see the code. So I hope that this part is not clear, but you, if you see the code, then it will be more easily clear for to you. Okay. Okay, let me code. If you understand, then you can code by yourself also, that will be good. A of n, first of all I given an element with the vector of a of n, I need to input all the elements of n. Okay, now I'm creating a vector of int, let's say I'm calling it mex from n. So the current mex is 0, and I'm also a count array of size n plus 1. So it is already said that all the elements are between 0 to n. Okay, so I'm to find the mex from each I, that is mex of I will represent the mex from I to n. Okay, I is equal to n minus 1, I greater than equal to 0, I minus minus. Okay, so first of all I encountered this element a of I need to plus plus. So I need to say that if the current mex, if count, if I encountered the current mex greater than 0, I will search for the next one. That's it. So mex of this up to this I is current mex. That's I want to say is that. Okay. So So you are not thinking that it will be giving a complexity of O of n square. If you're saying that this MEX is also running, this while loop also running, and this is also for loop is up to n, so it kind of a n square complexity. So I'm saying that it will gonna give me a complexity of O of n. Why? Yeah, the first of all, the for loop, that the outer for loop that is running of n times, that is, I'll say n times. But you will also gonna see that the MEX value can be maximum up to n. So that MEX will be in all the cases, like from 0 to n, it will gonna run into only n cases. So it will give me a total complexity of n. It will be gonna give me n square when for each n, for each like 1 to up to each one, it will running for n. If it is running n times n times n times, so total will be n square. But it is not, it is for overall, for all the n's, it will be running only n times. So it is not giving me n square complexity. Okay, so we are just calculated upon our first task. That's out. Now I'm starting from less than n I plus plus. So what I need to chase a of I, sorry I, and what the MEX can be. So I'm saying the current MEX is equal to, that is, I need to find the maximum MEX will be from I to n, that is this one. Okay, so I need to create a set of int s while j is less than n and set of size is less than MEX. If it is less than, we are gonna uh, running in the loop when we found that all the elements from 0 to n, that so it is possible when we got a size of s equal to MEX. So I'm seeing that if a of j is smaller than MEX, I'm going to insert it into this set and increasing the height. Yeah, of what happened. Yeah, now it is cool. So we have to create an array b push back, that is the current MEX. That's we have to do. That's what we have to do. Okay. Yeah. And I also say that I will be, so I need to search for the next segment of the array. So if I'm already reached to this point, from here like from a1 to a4, I encountered the MEX. So now next one I have to search from here, start search from a5. So it will be, that is j minus 1. So okay, but if MEX is equal to 0, that is current MEX, I will say I plus plus. Why it is so? If current MEX 0, so it will all it will not be gonna in this one. Okay, in this while loop, because size is 0, as size will be always 0, current MEX is 0. So it will not enter into when the MEX is 0. For that I need to overcome from one of the element, because if I just having one element, so MEX of these element, this one element is always 0. Yeah, now I need to output b less than b dot size cout b of I. I think so it is working. Yeah. So this is our second problem. Node assigning. Okay. You are given a tree of n vertices number from 1 to n with edges number from 1 to n minus 1. A tree is connected and undirected graph without cycles. You have to assign integer weight to each edges of the tree such that the resultant graph is a prime tree. A prime tree is a tree where weight of every path consisting of one or two edges is prime. So a path should not visit any vertex twice. Okay. The weight of path is the sum of the edges weight on that path. Okay, print any valid. Okay. So what we given is that we just can't given a graph. Okay. We are just given a graph. We need to find out, can we assign some number, let's say some number a b c d, such that one or two edges, so all the element one, that is from here to here and from here to here. So a plus b are both are what is prime, and if I'm starting from here, that is b plus c b plus d. These are kind of from these two, one or two edges, that is one edge is this one, second edge is this one, all are sum is prime. Okay, so first of all I will just come up with all the, first of all what we need to do is I need to draw what are the possible graph can be. So I'm saying it is n minus 1, so though so there is no cycle present, it is 100% clear because there are only n minus edges, it is all connected. So this can be the array, this type of graph structure can be possible, like having more than edges. This is also graph, or this type of graph is possible. It is saying that it is having at most two edges for any node. Okay, so I'm saying that 100% this type of graph will be present, this type of graph is not present. Okay, so first of all what I do is how to approach this problem. uh, Try to output how many possible of graph can be possible. Okay, then try to eliminate all those and try to kind of filter out the problem, because why it is not possible. So it is, let me say that. Okay, so first of all, let's say I'm taking out this portion, that is one node is connected to four of them or greater than two, let's say for two only. I'm saying that 2 is also not possible. Okay, if 2 is not possible, then 4 is also not possible. So I'm saying that first of all I need to output as a prime, that is sum of a b c. So a will be prime, a plus b is prime, and a plus c is also prime. That what I need to so if it is true, if it is possible, so this condition must be valid, that is a is prime, a plus b must be prime, and a plus c must be prime. Okay, so let me for you, let me print all the prime number. Prime number are 2, 3, 5, 7, 11, and all. So you can see that all of these are odd numbers, this is only the even number. Okay, so let's say I just assign I any some odd number, that is one of these from this one. Okay, now a plus b. So if it is 100% clear that if I am assigning a is odd number, so it always a plus b need to be, what it need to be, it need to be odd, because if assigned to this odd, that means it I'm assigned from greater than or equal to 3 element. That is 100% sure, because all these prime number are greater than or equal to 3 which are odd. So if it is greater than equal to 3, I'm adding something here, so it will always be greater than equal to 3. So, and if I need to be a plus b is equal to prime and it is greater than 3, then I'm 100% sure that if n is prime and greater than 3, I'm 100% sure that that will always be odd. So this is odd. So when what value I need to put here so that this is always odd? So odd plus odd is even, you know that. Okay, and odd plus even can only be odd. So I need to put here is even, but I have only one even. Let's say I will put here 2. Okay, and I know that 3 plus 2 is equal to 5. 5 is already a prime number, so this condition satisfied, this condition satisfied. So I need to output a plus c. Okay, same condition for a plus c. I need to output the prime. It should be the prime number, so it is should be prime. This is odd, so it need to be, it is greater than 3. I need to output here so that it will be odd. So it is only possible when it is 2. It is even and we have only one even number, that is prime, that is 2. Let's say that this condition be satisfied. So if it is I put 3 and these both to be even, so this is 2 and 2. Now if I put these both two are even, for now for uh, this edge, for this one, for this node, these three conditions will gonna be satisfied, but for this node, this node gonna be satisfied. So the sum will be 2 plus 2 for this of path length 2. So it is not satisfied. Okay, that's I want to say is that, so it is never be possible to take uh, any of the node having more than connected more than 2 times, because I have only one even number percent, and even plus even, or and you can see that by the way, if I output here odd, here even. Okay, so it will, so the path from here to here, this path is odd plus even, that is odd, that is 100% okay, we can get any odd. Okay, but if you see this path, if you output put here odd, then odd plus odd is even, so even never be a prime number. Same here, and I'm saying that it is always greater than 3 because these two odd primes are always greater than 3. So some, if those two are greater than 3, the sum is always greater than 3. And if I put even here, then this path sum is always even plus even, that is even, that is not prime. So it is always, so this type of graph cannot be there. So only this type of graph can be possible. So I filtered out this problem into, now the problem becomes very simple. Okay, now we filtered out that graph can be possible of this type. So first of all, okay, so like this problem becomes very easy. You can see that. Now what I will do, I will just output 2 3 2 3 2 3 2 3. That's it. You can see that every one or two edge is always be prime. So you can see that if you start sorting this problem into or trying to what is given into the question, according to that, if you are trying to sort this problem or filter this problem, you will easily solve this problem. So first you have to like think, okay, this can be possible, this can be possible. So which type of graph it is possible, which type of graph is possible, and I come up, oh, this type of graph is possible. So if this type of graph are possible, only solution, then it is will be very easy solution. Okay, so hope everybody understand this problem as type of very simple problem. Okay, so let me code for you, and if you know about if you actually understand this problem, so code by yourself. Okay, what I'm given is n, and I need to create a graph. factor. By the way, graph is not needed, we can use, because I not always know that it have only one value. Okay, but this is all. Okay, so I'm doing, I'm just creating a graph of size n plus 1. Now from 1 to n I need to clear this because the previous test case value will be there. Okay, what I need to do, so what I need to output all the elements which are need to assign for the this edge. For this thing I need to verify which edge this is. Okay, so I need to input a map for edge so I can understand uh, uh, which edge this one is. Okay, so there will be n minus 1, yeah. So map pair 1 2, yeah. Now I will input all the will be n minus 1, sorry, all the edges will be a b. So I'm saying that g of a dot pushback b and g of b. I'm making any graph. Okay, this is a standard how you make the graph. So I need to also make that, I need to identify the this edge later on. So I'm saying this can be a or ba. Okay, I found out if I'm just taking a and b, so this edge will be the ith edge that I want to know is, because I need to output for every edge, for the ith edge what will be value I'm assigning it to. Okay, so for I is equal to 1 I less than n. So in the problem what I'm going to do is, I know that this type of graph will be possible. Okay, from this one I need to find any node that having that is the end point. So I'm from this point I'm trying to assign two next three, two next three. So which how to find out this node? So I'm saying that any node having only one connections, or having one connection, this will be the my node. From here I'm just applying DFS. That's what I need to do. Okay, first of all I'm checking if any of size is greater than 1. I'm saying it is never, greater than 2, sorry, it is never possible. Just output what need to minus 1, and I will return this function. And the start point will be if size of I, that is I need to find the end point, or the size that is equal to 1, that start point is equal to I. Okay, so I will run the DFS from this start point, and what I need to do, a parent and result. I need to identify the edge, then M. I think that that's how. Okay, so DFS, first one is V, another is parent is okay. Yeah, we need to find parent. Then result is what will be the result, and map of pair of int comma int parent. And so I'm just applying the over all these child of G, and I'm saying that if it is all P, it is this parent. So I'm saying continue please, otherwise F B P res and M. So I'm saying that the res of for current value, what is the current index for this one is having parent v, there is a node between v to I, so I need to find out what is the index of this. Okay, I need one more element, that is value, int value. Let's say I'm sending here is 2. Okay, is value. So I need to change alternatively. If value is equal to 2, now I will say it will be 3. If it is 3, so I will say value will be 2. That's it. After every edge, I'm just changing the value. That's I want to do. And after that, I need to just output the n arrays an element. Yeah. For int I is equal to 0, it has then ni plus plus. That is, sorry, I minus 1. Because there are only n minus 1 edges. See out rise of I. Okay. What the fuck? T test cases, then I'm taking the n element, and after that making an for identifying this edge, I need to make an array, a map, sorry, m. Then for the result, m, I'm just researching the g, that is n plus 1. From 1 to n, I'm just clearing, that is totally fine. I'm taking n minus 1 edges ab, that is a push back b, b push back a. Okay, now I'm thinking if it is greater than 2, I'm output minus 1. This is my starting point, 100% fine. From now, I'm just starting the DFS from the starting point. Parent is 0, result m and 2. Then I outputting the. That's why it is showing this shit. Vn res m. Map int. Oh man. Pair of int comment. So m of v comma it is equal to value. It will gonna give me index. So for this index, this is the value. So now I'm changing the value. I'm saying that it is 100% correct, man. Why it is segmental? So let's debug this. So the error will be on the DFS term in this function only. What are we doing wrong? I don't think so. We are just doing anything wrong. It is maybe according. Oh man. Oh yeah, I got it. I got it. So I'm just need to it. Yes, otherwise it will be running a endless loop. That's okay. Yeah, 322. Let me check. Um, Here we go. This is the third problem. Palindromes coloring. So you have a string S consisting of lowercase Latin alphabet letters. You can color some letter in color from 1 to L, 1 to K. It is not necessary to paint all the letters, but for each color there must be at least a letter painted in that color. Okay. And then you can swap any two samples painting in the same letter as many times as you want. After that, k string will be created. The ith of them will be contain all the character colored I written in the order of the sequence in the string. Your task is to color the character of the string so that all the resulting k string are palindrome, and the length of the shortest of these k string is large as possible. Okay. So basically, what we need to do is we have just string s. We are just given a string s, and we have to divide into k strings, such that they are palindrome. So k palindrome strings. Okay. so that the length of the smallest one is maximum. That's what we need to do. So okay, so I'm saying that all these include all the elements from A to Z, that is only 26 elements. Okay, so okay, I'm having now, let's say A having 5, B is 3, C is 4, D is 6, something like that. Okay, so when I'm gonna, I need to, what I need to do, I need to do some kind of a palindrome. I need to make palindrome strings. So when I'm gonna make palindrome string, so let's say I'm taking all the all the values in the pair in the sense I am taking pair of 2 2. So from these I'm taking 4 a's. Okay, 2 2 from here, or I'm taking the only even values here too. So from the even values I'm saying that I'm always gonna make palindromes, because if evens are two, so one I'm just putting here, one I'm putting here. So no matter the string was, it is even length, odd length. If it is like, if it is length one, it is odd length, so it will gonna me sorry, not odd even, yeah, odd or even length if it is already palindrome. So I'm just saying that if a length, if a string is already palindrome, then applying these two elements, that is two a's of same character, I'm gonna make this string palindrome. This string will be palindrome after the applying these two elements. So I'm just taking all the elements to the pair. Okay, the 4 and 6. Okay, let's say the total number from now, from, so total number of elements I have 4 plus 2 plus 4 10 16. So I'm saying that these 16 element can form palindrome strings. So I will say how many string I want. Let's say I want k strings. K is, let's say, 4. Okay, so the length of each string will be, what is the length, that is 4. 16 by 4, I need to divide 16 element character into the 4 strings, so length will be 4. So I'm saying the maximum length can be 4. That what I need to do. Now you can say that if length is even, okay, so length will be something look like a b b something, or I can say that. So yeah, this will be one of the example of these 4 strings. So I'm saying that okay, I have actually I am taking the odd ones. Okay, now I have something remaining, that is 1 1, that is 1 a is remaining, 1 b is remaining, some elements are also remaining. Can I also input in this? So if I'm saying that if the length is even, let's, this is the even length, if I'm putting this of one element, I'm putting b c or any element, they still will remain palindrome. Are you agree with this? Of course this will gonna be remain palindrome. Okay, so I'm saying that okay, let's say I'm just having 16 variable divided by k, let's say 4 is come out, that number of string, the smallest length will be come out my this. So I can make k string of length 4. Now I'm saying if the length is even, if, and I'm gonna say that if the length is even and I have to make k string, and if I am having k element in remaining here, so if I am having the k element remaining here, so I can put one element in the each string in the middle. Okay, if it is so, if it is k, the number that I remaining here is greater than k, so I can easily put one element in all these k string, so its length will be gonna increase. So it's, if it is length 4, I'm gonna say it is 5. Yeah, very simple question. Yeah, that what we want to do. I think so it is 100% clear for all of you. We just need to take all the element in the pair, because we need to make the string in palindrome. Okay, so what we are given? We are given n, k, n and k, n and k. Okay, and a string s. I will gonna make what is the count of each character. Character will be 26. for I is equal to 0, I less than 20, I less than n. Iterate over the string and increase the count of this. So I'm converting into SI value. So what is gonna this will gonna correct convert into SI value. If it is A, it will I S of I minus A will be given 0. If it is B, S of I character is B, so B minus A character will gonna 1, something like that. So it will gonna be string from 0 to 26 values. So I am iterating over all the values from 0 to 26. So I need to find the uh, one total values total I can use for the string making. Okay, so total will be I need to take total plus the size of S of I, A of I. Okay, now if A of I, so I need to take only even pair. If it is odd, what I need to do, I need to just minus 1. Okay, if it is like 3, I'm adding 3 in the total. Now if it is odd, I'm just subtracting 1. Okay, so number of strings will be number and strings will be how much string from these word I have these total number of element which can form palindrome, and I need to form k palindrome. So I can say the count of string will be this many string I can form. So I need to uh, also say that how many character is remaining. So I have already n characters, and how many used, count for each k string, that much is used. And if I'm saying that if the length, so the count is the length of each string. Okay, so if the length of each string is even and the remaining element is greater than or equal to k, I can say I will increase all the length will by 1. That's it. I need to output the count, that is the size of the number of elements or character in a string. Okay, let me output if it is giving me correct solution or not. 321151333 321151133. Yeah. Okay, so this is the last problem of the day. So while performing complex matrix of market analysis, William encountered the following problem. For a given array A of size n and a natural number, he calculated the number of pair of I comma k which satisfy the following condition. Okay, so k must be greater than 1. Okay, so we need at least two numbers. Okay, I and I plus e k is less than n. Okay, so it, so it will be pretty clear. So what we're gonna do is, first of all, we are saying that we have a1, a2, a3, a4, a5, a6, a7. Okay, let's say I'm having the like e is equal to 2, 2, let's say, or 3. So for I is plus 1 first element, then second element will be 1 plus k will be 3, that is 4, then plus 3, 4, 3, 7. So these element, next two element where plus 3, 5. Yeah, this. So you can see that I can make of like, and let me separate out it now. 1, 4, 7, a7, a2, a5, and a3, a6. So I'm gonna form like these chain will be there for these elements. Okay, or these all type of element, so these chain will be there. If it is, maybe many chain will be there, so total element in all these chain is a of n. So now I need to do all the operation in these chains, in these. If I'm saying that I'm creating the vector for all of these chain, so first of all I'm just taking out all these in a vector. So this is a vector of a vector. Okay, or array of array. So now, first of all, I separate out according to the these pair, that is I plus E of k, because I'm gonna apply the operation in this one only. Okay, because if this is A4, I'm starting from A4, I can only apply I plus E, that is the next one, that is A7. So these kind of operation I can apply only the all the element that is in a particular vector that I am separating out. Now the problem become easy. So we have an array, okay, and we need to calculate the product of all these elements is one or not. How many possible is that? So I'm saying that, okay, so not one. So product of the elements will be prime. So when it will be prime, so I'm saying that it will be prime. So you have to notice that one is not a prime. Okay, one is not a prime. So prime number are 2, 3, 5, 7, 9, 11. Sorry, 9 is not a prime, something like that. So I'm saying that if it is a prime, let's say this prime, this is a 2 number, the array is 2. So and having 1. So this condition can be satisfied only because like a of I into a of I plus E plus a of 2i I plus 2e. That's just a of I plus some ke. This condition is satisfied, so we need to output it as a so the product is prime. This is only possible that one element is prime and all other are ones. Okay, because the product of two primes is not always prime, like 2 or 3 are primes, but the product 2 and 3 is not a, that is 6 is not a prime. So this is only possible that there is only one prime and all other are ones. That's what we want to do. So we just find out all the vectors. Okay, now we have to play with the vectors. So we have vector. So for, let's say, this is in any of these vectors, this is the prime vector, the prime element. So prime element can be, let's say, I'm just defining it by p. So I need to find out how many ones that is on the left side and how many one in the right side. Let's say 3 are here and 4 are here. Now how many different I comma k combination I can form? That is my task. So basically I am already separated out all these chains, that is of I plus E plus k. So you always see that at least two element is required. So you can say that, okay, if 2 3 3 3, I'm saying that 0 I comma k pair will be there. I comma k pair are these pair, the natural I comma k, because first of all the first pair will be a of I, and it is always saying that a I comma k is always greater than 1. So you can see that in the starting, first is a of I and second is I plus E. I plus E means k is 1 and k has to be 1. So at least two element uh, should be there to satisfy a condition. Okay, so we need to find out how many uh, pair will be possible if I'm just calculating, okay, by somehow I'm just calculating that for any prime, for this one of the array, I having x1 on the left side and y array is on right side. So how many things are possible? Okay, so this is b. First of all, let's say 1 must be there, so at least the size will be greater than 2. Okay, so now I'm starting, this is the my the p element, that is the prime element. Okay, now what I need to do is I'm taking 1 1 1 1. I'm taking one array with this one, so I'm starting from this I. So this is the I, this is I plus E. Okay, so and after that I know there are y elements. So how many different pair can be possible? And say that, let's say y plus 1. Okay, y plus 1, let's say y is 2. So 1 prime, that is I'm noting taking any of the one, then this one, this one. So maximum number of 1 after the p is that 2. So how many possible? 1, 2, 3. That is y plus 1. Because the empty case is always there. Empty and all the y cases. Okay. Okay. I'm saying y plus 1 cases are possible. And I also know that there are x ones are there. Okay. Okay. So x ones are there. So this is, if I am starting from x is equal to this one, then let's say x is equal to 3. So I'm starting from this one, I'm getting y plus 1. I am starting from this one, I'm getting y plus 1. I am starting from this one, I'm getting y plus 1. Something like that. IP, then IP1, IP2. From 3, if I starting from this I, if I'm starting from this I, the value will be 1P1, 1, sorry, this is nothing. 1P1, then 1P2. Okay, I am starting for this third one, same thing. 3 will be, I'm getting 3 combination. So I'm saying that the total combination I'm getting x into y plus 1. Okay, if there are x number of ones here this side and y number of this number is this side, so total number of answer will be y plus 1. Now I'm saying that I'm just fixing the one in the this side, that is on the left side. Now what will be the result? So some result will be there, that is I'm fixing the y on left side, because what operation I will take, I'm always having one on left side, I'm always having. Okay, you can see for all these uh, the cases will be, if this one, or I'm taking one on left side, if I'm taking two on left side, these are the cases. Okay, now if let's say I'm not taking anything on the left side, then how many are possible if I'm not taking on the left side? So for the satisfaction of the this theorem, the second part, that is this one, it should at least having two elements. So p1, p1, 2, these are can be possible. And these how many are? These how many are? Y only. So the total number of if having x this side, y this side, so total number of x, y plus 1 plus 1 plus y. Okay, if you doing the, if first of all you are fixing on the y side and doing this, you will gonna encounter same number of result. How it is? So like if you open this one, okay, so the result will x plus y, x, y. And if you taking y common, so you y common, then x plus 1 from y, that is x plus 1 plus x. So you can see that this is equivalent this one. Okay, so xy, it is not any issue. If you are taking this one as xy, if you are interchanging, so answer will be same, that is will be uh, you have to take one side of the, that is y, and another side is x. So there is no difference. Let's code. So let's code this problem. If you literally understand, then you can code by yourself. So I have n and e, in n and e, c, n and e. First of all, I need to create a vector of vector, so I'm just creating v, and I'm vector of boolean bt of size n, and vector of type int a n element. For I to n, I'm taking all the input. Okay, now for int I is equal to 0, I less than n, I plus plus. So I will say I y while j plus e. I'm just increasing the g type of chain. Okay, is less than I, and it is not visited already. That is j plus e is false. So I'm including in, I'm creating here a vector temp. So I'm saying that temp dot pushback. What I need to push back, a of j. j plus e, sorry, and I'm making visited, this is visited, j plus e is equal to 2, and I'm increasing the j, so it will gonna be a vector of a chain. Okay, so I'm pushing back this to v, that is 10. Now I have to, let's say answer is equal to 0. I'm visiting all over this v vector. So let's say I'm creating the vector now is equal to 8. I need to find out how many ones are present in this side and this side. That's why I need to find out. Okay, first of all, I need to find out if this current element is p or not. So p in the sense this is prime or not. So this is a very classical, or I say very famous algorithm, sieve algorithm. So I already write this, so I'm not gonna write that algorithm. So this is the algorithm. Okay, if you're gonna search, you will gonna easily find this algorithm. So similar algorithm where you can find CP algorithms. CP, basically I'm mainly use this site for taking mm, of learning, any type of learning, or taking any side of a contest. I'm taking only this site for all the algorithms. So you can see that CU analysis will be there, but where it is, where the C, yeah, CO of reference. So this is the same algorithm. You can easily, if you see that I'm using which one, yeah, this will be the algorithm. No, this is yeah, having the they are just they were elaborating these sieves, these algorithm very, you can say very easily in very uh, using the time complexity, space complexity. They are reducing in some part, they are reducing time complexity, they are reducing size complexity, and trying to make the sieve, trying to make the, sorry, algorithm. Okay, so very good explanation is there, so you can see that, you can even read that, and some problem, practice problem is there. So if you understand the, like, the algorithm, so you can solve the problems. Okay, so this side is completely for CP, there is nothing with the DSA kind of thing in. Okay, so this is only CP related. Okay, so in kind of complexity and time complexity, they are giving the best algorithms, I think so. And yeah, these are the best algorithms. Okay, so I need to first int maximum, I need, okay, what is the size of the element, each element 25. Okay, I'm good. Plus 10, I need to output sieve. So what will gonna, according to sieve, if I'm just making an, I'm just giving a brief overview. What you're gonna do, what you're gonna do is that I need to make it fix. Okay, yeah. So what we will going to do, I will create a SPF, okay, of as vector kind of thing, array of size, the maximum size of the element size. And now I'm just trying to run the algorithm when, where I got the SPF of I is equal to I. Okay, so it will include the divisors kind of thing. So SPS will be include the factor, you can say the divisor or a factor. So if they are both same, that means this is the sieve, this is the prime element, sorry, this is the prime element, prime number. Okay, if you don't know about this algorithm, so please have a look, this is very useful algorithm. Okay. I will need to count the elements, the size will be size, int size, okay. So what we are just doing yet, we are just having a separating out the chain in a vector. Now I need to find out how much element, how much ones in the left side and right side. Okay, so for int I, for finding in the left side, I'm just creating an array that is of size of, that is count I plus plus. I'm making int count is equal, let's say cc is equal to 0. I'm saying if s of, that is now, the current element is now, uh, now of I is equal to 1, I'll gonna increase this my cc. Else I'm making, if it is not 1, I'm making is 0. And count of this I, that is the count of this I means from this to the other. Okay, I'm gonna explain this thing. Okay, so the thing is, we having 1 1 1 2 1 1 1 3 1 2. So I'm just making a cc element, cc variable that will be increase the number of ones when it can encounter 1. So here the cc value is 1, here 2. Now the L, now it is not a 1, it will gonna increase with 0. Then here 1 2 3. So for this element, if this is a prime number, so I'm saying how many ones in the left side. So just this one, that is the count, that is 3. I'm gonna find out by this way. Okay, okay, that is the cc. Now for, I'm just tracing over this array I is equal to 0 to size less than ss I plus plus. Now I'm saying if this is prime, how to know about that this is prime? I need to say if now of this, the current element is this one, let's say z is equal to now of I. Okay, in the using the sieve, if say if the divisor of this is the same, what I'm saying that the spf will gonna having the, if you run the sieve, okay, this algorithm, so this will include the divisor of this, and if this having the same divisor, that is like 2 having the divisor 2, that means this is only divisible by 2, so it is a prime number. So if it is a prime number, I need to create another variable, so that is the first count. So if it is, if it is 1, if z is equal to 1, I will make first count is equal to plus plus. Else if it is a prime, if it is a prime, what I need to do, I need to answer. So answer will be, how much it will be, so I already told you now, y into x plus 1 y, let's say I'm just taking a y is, or it will be good, I'm taking it as y, that will be fine. So y into x plus 1, but x is count of I plus 1. Okay, x plus 1 plus y. Okay, I'm just using this same one, for x, sorry, this will be count I plus 1. Okay, yeah, if I'm, this is x plus 1 x plus 1 x, yeah, I will gonna make it long maybe, and here the y will become 0, that is y is the number of, it is a number of ones in the right side. So let me output the answer. Mhm. Segmentation fault, where it is in the segmentation fault. Okay, I'm having this vector v, then with t of size and a of size, and I'm taking a, I'm iterating over all the, if it is less than n, it is, yeah, and it is not visited, I'm just making it visited, and it is j plus plus e, making this one. So if over this, for the current chain, I'm making a new array now, the size is ss, this is the ss size, so I will be okay, I need to make it minus 1. Yeah, shit man. Don't think so. Yeah, that's not the answer. Okay, so this now if I say that now if I is 1, CC I'm gonna plus plus. If it is else, CC make a 0. So count of I is equal to CC. That is the number of from this from the last that one. How many number I have? That is count CC. Okay, that is fine completely. If I'm just having this one, yeah, I need to make it size 1 plus 1. Why it is so? Because here I'm just taking I plus 1. If this current value is at I minus, it is the last element, so it will be fetching any value. Okay, I plus 1, any value or give me error. Yeah, having something right, but the answer is not good. Uh, I'm saying that this is current size s5 plus plus. If z is 1, I'm gonna make it answer. Answer will be 5 plus 1 plus 1. Okay, x into y plus 1 into y. Okay, it will be y into. That is 100% correct, man. Okay. Does I make any mistake or something? Let's say for the sake it make x, that is count of y plus 1. Now I'm seeing clearly. X into y plus 1. That is completely fine. Okay. This must give the correct. Okay. So this is saying this is the first. Let me output over this. What the value of xy I'm getting? Getting x. Oh shit. This x y. So oh fuck man, always 0 0. How it is possible? So 3. If I'm having plus 3 this one, then plus 3 this one. 4. I'm having. So what are the answers? I'm getting 2 for this one. So 1 this, if I'm getting this. Okay, so let me output what is the vector I'm getting. If I'm getting vector are correct or not. J plus E, current is I. Okay. Oh man. Yeah. Yeah. I need to insert first the J element. That is VA of J. Okay. Because I'm inserting the J plus E. The first element is not inserted. That is A of J. And if A of J is visit of J is already done. Let me see. It is here. Visit of I. It is already visited. I may continue. Dot pushback. Yeah, here we go in the answer. 2. How many test cases are? 6. 2025. 2025. Yeah, here. It. Yeah, let me submit this solution. Oh, I need 100% sure it will be one long. Yeah, here it will be saying that out of bound and the same. Yeah, it not be some out of bound thing. What the wrong I'm getting? Expected 104, I found 111. So let me see my solution. Okay. Hmm. If it is visited, I will continue. If it is not, from j is equal to I push j, then push back j plus e. All are p. Okay. I need to say visit of j is also true. Yeah. Now let me check once. Yeah. Shit, man. Oh, ho, ho, ho. This problem be interesting. Mm-hmm. So if you can debug by yourself. So I'm making true. If it is visiting true, I will push a of j here. That is a of j. Then I'm pushing a of j, making the temp, and at the last pushing that one. That is completely fine for me. Now taking the vector. Now vector size is this one, so I will making s plus 1. That is completely fine. So ss minus 1, I greater than 0, I minus minus. Now I'm saying if it is 1 plus plus, I will say count will be count of I is equal to that much. Okay. Now for if sieve is running properly or not. 1 e power 6. Sieve is 10 to the power 6. That is completely fine. It is 10 to the power 2 and 10 to the power 5. Okay. Let's see for 5. Oh, if it is 1, then it will be giving me the this one. Okay. So if it is 1, then it will be giving me, yeah, but I'm just using s plus 1. So I'm taking creating y element. If it is 1, I'm making y plus plus, and now element, if sp of z is equal to z, that means this is a prime. If it is a prime, I am saying that how many in the x will be the number of 1 in the left right side, and y is the number of element in the this side. Okay. So x I'm going to take count I plus 1. That is absolutely 100% right. I'm just thinking so. Yeah, it is. And um, y into y plus 1 x plus y x plus y. Okay. This should give me. So let me check on which test case it is failing. So in the first number differ only the first number, then that is complete. So it's saying 1 1 1 3 4 14 10. Why it is failing for this one? 104 131 104 13. It is all the answer are correct wrong. Mm-hmm. Yeah. So what is happening here? 1 2 3 4 5 6 8 into 10 to the power 5 number. It is also perfect. We are having a number greater than I'm running the sieve. Number are greater than maximum. That is completely fine. That is not overwritten anywhere else. Yeah. 1 e 10 to the power 10. This should be run. Okay. I think but it is happening on N and E. I'm using A plus I. Then temp A of J, I'm taking B of J is correct. Temp dot pushback A of J is the first element. Okay. Yeah, okay. Okay, I'm got the point. Else y is equal to 0. Why it is so? Because if any number that is uh, not that this is not, if it is y it is not 1, that is I'm increasing y is 1, I'm increasing y. Okay, that's the number of 1. Okay, if it is z, if it is prime, I'm also increasing. Now when it is not a 1, not a prime, in that case also it should also and say that it will y the number of uh, 1 is equal to 0. Let me see if this is gonna work or not. Yeah, it is. So we are just making a small problem because we are just, if it is not 1, we are making it 0, y is equal to 0. So here we have to take care of this case. Like it, if it is not 1, not prime, so something else is there na. Let's see if it is 6. So 6 is not 1, 6 is not a prime number also. So for that we have to make y is equal to 0. Okay, bye bye.